This is an equilibrium question. We will find out which statement about this reaction is correct. A. Water and this aluminium species are a conjugate acid-base pair. Conjugate acid-base pair means two species differ by a hydrogen ion. So let's look at this reaction. We have two aluminium species here. Left hand side, right hand side. Left hand side aluminium ion is bonded to 6 water molecules. Right hand side, aluminium is bonded to 5 water molecule and 1 hydroxide ion. So the difference will be 1 proton. So the species on the left loses 1 proton and became the species on the right hand side. So these two complex ions of aluminium, they are a conjugate acid-base pair. Another conjugate acid-base pair in the reaction will be water and hydrosonium ion. From H2O accepting a proton became H3O positive. So the difference again is only 1 hydrogen ion. So these two are also a conjugate acid-base pair. In the 2022 to 2024 syllabus, conjugate acid-base pair has moved to A2 syllabus. So do not worry about this for identifying conjugate acid-base pair in the reaction for AS anymore. So answer A saying that water and this aluminium complex are a conjugate acid-base pair is not correct. So A is not the answer. B, water is acting as an acid as it is donating a H plus ion. Just now when we tried to identify a conjugate acid-base pair, we saw that water accepted a hydrogen ion to form hydrosonium ion. So it is actually a base that is accepting a hydrogen ion. So again, B is not the answer. C, if hydroxide ion is added, the equilibrium will move to the right. Now, inside this equilibrium, we have 4 different species, but only 3 of them are aqueous ions, so their concentration can be changed. Adding hydroxide ion to the solution, to the equilibrium, hydroxide ion will react with the hydrosonium ion because one of them is a base, the other one is an acid. So they will both undergo neutralization to form water. So that means adding hydroxide ion, the concentration of hydrosonium ion will drop. When concentration of hydrosonium ion in the equilibrium is reduced, equilibrium will move to the right-hand side to increase the concentration of hydrosonium ion in the equilibrium again. So statement C is correct. Now let's look at why statement D is not correct. Kc varies as the pH is varied. Changing the pH will change the concentration of hydrosonium ion again. If pH is low, that means acid is added or H plus ion is added. H plus is the same as hydrosonium ion. So when pH is low, concentration of hydrosonium ion is high. So equilibrium will shift to the left-hand side, but there will be no change in Kc. If we increase the pH, which is the same like the effect in C, we are adding hydroxide ion to increase the pH. So that means concentration of hydrosonium ion will be reduced. Then equilibrium will shift to the right hand side, but again there will be no change in Kc. Kc, the equilibrium constant will only change with temperature, but not concentration, so D is incorrect. Therefore, our answer to this question is C.